Time doesn't go backward, but not for the reason you think. Right now, you believe the universe has a built-in rule preventing time travel to the past. You imagine some cosmic law that says thou shalt not reverse time, but here's the truth that will shatter your understanding of reality. Physics has no such rule. Every fundamental law of physics works perfectly in reverse. Drop a ball, and Newton's equations describe its fall. Run those same equations backward and the ball flies up from the ground into your hand. Both directions are equally valid. Both follow the laws of physics perfectly. Electromagnetism, quantum mechanics, even Einstein's relativity, all of them are completely time-symmetric. The universe doesn't know the difference between forward and backward. So why can't you travel to yesterday? The answer will blow your mind. You can't go backward in time for the same reason spilled coffee doesn't spontaneously jump back into your cup. Think about that coffee right now. When you spill it, the liquid spreads across your desk in a chaotic mess. The molecules scatter randomly in billions of different directions. Now imagine playing this scene in reverse. Every single coffee molecule would have to perfectly coordinate billions of them moving in exactly the right direction, at exactly the right speed, at exactly the right moment to flow backward into your cup. Is this impossible? No. It's just overwhelmingly unlikely. Feynman calculated this in his statistical mechanics lectures. The probability is so astronomically small that it would take longer than the age of the universe for it to happen by accident. But here's the kicker. If it did happen, it would follow the laws of physics perfectly. No rules would be broken. This leads to Feynman's devastating insight from the character of physical law. Time zero isn't built into physics, it's built into probability. Let me show you what this means with a simple thought experiment. Imagine a perfect video recording of any physical event. A falling apple, a bouncing ball, two colliding billiard balls. Now play that video in reverse. At the microscopic level, every atom, every force, every interaction still obeys the fundamental laws. Newton's laws work, Maxwell's equations work, quantum mechanics works. The reversed video shows a perfectly legal physical process, but you immediately know it's running backward. Why? Because the forward direction shows one organized state becoming many disorganized states. The backward direction shows many disorganized states spontaneously organizing into one perfect state. One coffee cup becoming billions of scattered molecules. Probable. Billions of scattered molecules spontaneously forming one coffee cup. Technically possible, practically impossible. As Feynman explained in 6 Easy Pieces, this is the second law of thermodynamics at work. Entropy always increases in an isolated system. But entropy isn't some mysterious force, it's just a measure of disorder. And disorder increases for a simple reason. There are vastly more ways for things to be disordered than ordered. Think of it like this. Shuffle a deck of cards. How many ways can you arrange 52 cards? About 8 followed by 67 zeros. That's more arrangements than there are atoms in the observable universe. Now, how many of those arrangements represent perfect order, say all suits organized from ace to king? Just a few dozen. When you shuffle randomly, you're almost guaranteed to get disorder. Not because there's a law against order, but because disorder vastly outnumbers order. This is why your room gets messy but never spontaneously cleans itself. This is why ice cubes melt but never spontaneously form in warm water. This is why you age but never spontaneously get younger. Not because time flows forward, because order spontaneously becoming disorder is overwhelmingly more probable than the reverse. Now here's where things get truly mind-bending. Feynman realized this means the arrow of time isn't about time at all, it's about information. When you remember the past, you're accessing traces of previous states, photographs, recordings, scars, memories. These traces exist because the past had lower entropy than the present. But why don't you remember the future? Because the future has higher entropy than the present. Information about future states hasn't been recorded yet in low entropy traces. Your brain evolved to extract information from entropy gradients. You experience time flow because your consciousness rides the wave of increasing entropy. Think about this. In a universe where entropy was decreasing, conscious beings would remember what you call the future and be uncertain about what you call the past. Time's direction isn't written in the laws of physics. It's written in the structure of information itself. But we're not done, because this leads to the most disturbing consequence of all. If the arrow of time is just increasing entropy, and if entropy is just a measure of disorder, then what happens in a perfectly ordered universe? Feynman explored this in his lectures on computation. In a completely deterministic universe with perfect information, there would be no arrow of time. Past and future would be equally accessible. Time travel wouldn't be forbidden, it would be meaningless. The only reason you can't travel to the past is because the past had lower entropy than now. Information about past states has been scrambled by billions of molecular interactions. But theoretically, if you could precisely reverse the motion of every single particle in the universe, time would run backward, not metaphorically. Literally, you would unscramble the information that defines temporal sequence. Maxwell's demon, a thought experiment Feynman loved, illustrates this. An intelligent being with complete information about molecular positions could sort molecules by speed, effectively reversing entropy and reversing time's arrow. Here's what really breaks your brain. This suggests time travel to the past isn't forbidden by physics, it's forbidden by information theory. Quantum mechanics adds another twist. Feynman's path integral formulation shows that particles actually do sample all possible histories, including ones that move backward in time. At the quantum level, there's no clear temporal sequence. Cause and effect become fuzzy. The arrow of time emerges only when you average over billions of quantum possibilities. You are made of particles that constantly violate temporal sequence at microscopic scales. The you that experiences linear time is a macroscopic illusion, a pattern that emerges from countless microscopic violations of time's arrow. So what does this mean for everything you experience? Right now you think you're moving forward through time at 1 second per second, but according to everything I just told you, you're not moving through time at all. Instead, you exist in a configuration space of possible states. Your consciousness tracks the path through this space that corresponds to increasing entropy. What you call memory is just accessing information encoded in lower entropy past configurations. What you call aging is just your biological systems moving toward higher entropy states. The flow of time isn't time flowing. It's your consciousness surfing the entropy wave from order toward disorder. You experience temporal sequence because your brain evolved to extract useful information from entropy gradients. Time's arrow points in the direction that maximizes information processing. Let's return to where we started. Time doesn't go backward. Does that make sense now? It's not because the universe forbids it, it's because the past had lower entropy than the present. Information about past states has been scrambled beyond practical recovery. The coffee spilled on your desk contains exactly the same information as the coffee in the cup. It's just encoded in a way that would take longer than the age of the universe to decode. Time travel to the past isn't impossible. It's just incredibly improbable. Like expecting scattered coffee molecules to spontaneously jump back into perfect formation. Every fundamental law of physics works equally well forward and backward. But the universe started in a very special low-entropy state, what cosmologists call the Big Bang. As Feynman reflected in The Character of Physical Law, this initial condition set up the entropy gradient that creates your experience of temporal flow. Without it, there would be no past to travel to, because there would be no meaningful distinction between past and future. You don't move through time, you are time, a pattern of increasing entropy that has learned to observe itself. Tomorrow, when you watch coffee spill and think, I wish I could reverse time, remember the laws of physics would allow it. But the laws of probability make it vanishingly unlikely. Time's arrow doesn't point forward because of some cosmic rule. It points toward the direction where information becomes more scrambled, where order becomes disorder, where the possible becomes actual. You are riding an entropy wave from the impossible toward the inevitable. And that journey is what you call time.